I am Pavagada Manjunath, lecturer in physics. In this video clip, I am going to discuss problems on the chapter electric charge and electric field. I have divided these problems into three parts. In the first part, I have discussed problems on Coulomb's inverse square law and electrostatic force. In the second part, I have discussed problems on electric field. And in the third part, problems on dipole moment, Gauss's law, and distribution of charges. I have selected problems from the material, legend study material for physics. Second year PUC, it is as per the NCERT textbook. It is written by experienced lecturers and it is helpful for the Karnataka board examination. In this video clip, you can understand problems very easily because I have used animations to explain the problems involve vector idea. Now let us discuss problem number 1. Look here. So this is the problem number 1. A polythene piece rubbed with wool is found to have a negative charge of 3.2 into 10 to the power of minus 7 coulomb. A. Estimate the number of electrons transferred from which to which. B. Is there a transfer of mass from wool to polythene? Calculate its value. So here, look here. So this is the, let this green one be polythene sheet and this one is wool cloth. When this polythene is rubbed with wool, electrons are transferred from wool to polythene. Few electrons are transferred. So by rubbing one cloth with another cloth, this is a friction. Due to friction, electrons are transferred. Number of electrons transferred we have to find out. So we know the formula. It is of course before that given charge on the electron is 1.6 into 10 to the power of minus 19 coulomb. Mass of the electron 9.1 into 10 to the power of minus 31 kg. These data will be given in the problem or they will be there in your mathematical tables provided in the exam hall. And look here, charge is given here 3.2 into 10 to the power of 7 coulomb. What is the formula to calculate the number of electrons? Here amount of charge is given, charge on the electron is there, number of charges we have to find out in order to make 3.2 into 10 to the power of 7 coulomb. That is, look here, A, Q is equal to N times E. We need number of electrons. This is number of electrons, this is charge on the electron. Cross multiply this one. We get N is equal to Q by E. And substitute for Q and E. We get that is 3.2 into 10 to the power of 7 divided by 1.6 into 10 to the power of minus 19. Coulomb get cancelled. And this can be calculated by using calculator. Simple calculator is allowed to your exam hall. So N is equal to 2 into 10 to the power of 12. So many electrons are transferred. Look here, from this wool to this polythene. So 12 into 10 to the power of 12 electrons are transferred. And next, what is B? Is there a transfer of mass? Yes, of course, because each electron has certain amount of mass. Therefore, transfer of electrons from here to here means there is a transfer of mass. How much mass is transferred? We know mass of each electron. Therefore, we can find mass of 2 into 10 to the power of 12 electrons. So here B. So look here, mass transferred is equal to, so M, mass of each electron into number of electrons. Look here, mass transferred is equal to, mass of each electron is 9.1 into 10 to the power of minus 31 and number of electrons transferred, here it is there. So 2 into 10 to the power of 12. And now on calculating we get mass transferred is equal to 18.2 into 10 to the power of minus 19 kg. So this is the first solution for the first problem. Next problem. Problem number 2. The electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 to the power of minus 9 Newton when they are separated by a distance of 5 angstrom unit. How many electrons are missing from each ion? Given charge on the electron is equal to 1.6 into 10 to the power of minus 19 coulomb. Now let us understand this problem. So look here, these are the two charges Q1 and Q2. They are positively charged. As electrons are removed from these two charges, they have become positive. So now the distance between these two charges is d. D is given 5 angstrom unit. As this Q1 is positive and Q2 is positive, Q1 repels Q2 in this direction with certain amount of force. Let it be F21. So force on second due to first one. At the same time, Q2 repels Q1 in this direction. It is given F12, force on 1 due to 2. Of course, these two forces are equal in magnitude but opposite in direction. They act along the line joining them. Now the force is given. Look here, that is 3.7 into 10 to the power of minus 9 Newton. And the distance d is equal to 5 angstrom unit. Angstrom unit means 10 to the power of minus 10 meter. Therefore d is equal to 5 into 10 to the power of minus 10 meter. And here we have to calculate number of electrons missing so that it has become positive charge. And Q1 is equal to Q2. Let it be Q. And now the formula for force is F is equal to 1 over 4 pi epsilon naught Q1 Q2 by d square. This is according to Coulomb's inverse square law. Now we know F value this much. Therefore instead of F, 3.7 into 10 to the power of minus 9 and 1 over 4 pi epsilon naught is a constant which is equal to 9 into 10 to the power of 9. And here Q1 is equal to Q2. Therefore Q into Q. D, the value of D is 5 into 10 to the power of minus 10 and square is there. Look here, this is the value of D. And now we need Q. Therefore Q into Q, Q square is equal to 3.7 into 10 to the power of minus 9. Multiply this one, cross multiply this one, we get 5 into 10 to the power of minus 10 whole square. Divide this one here, 9 into 10 to the power of 9. And here Q square is equal to, so 3.7 into 10 to the power of minus 9. This square is there for 5 square and 10 to the power of minus 10 square. 5 square is 25 and 10 to the power of minus 10. 10 2s are 20. And here 9 into 10 to the power of 9. Now multiply 3.7 and 25. We get 9.2 into 5 minus 9 minus 20, 10 to the power of minus 29. Look here, this 10 to the power of plus 9 becomes minus in the numerator. Therefore it becomes 10 to the power of minus 29 minus 9 is 38. So now divide this by 9, we get this much, that is 10.2777 into 10 to the power of minus 38. Here we need Q, transpose this square, it will become square root, and square root of this 10.2777 is 3.2 and 10 to the power of minus 38, it comes out of square root as 10 to the power of minus 19, because 38 divided by 2 is 19. This is the charge on each charge. So now we have to calculate how many electrons have to be removed in order to make the charge 3.2 into 10 to the power of minus 19 coulomb. So we know this N is equal to Q by E. So Q we have calculated, E we know, charge on the electron. So that is 3.2 into 10 to the power of minus 19, 1.6 into 10 to the power of minus 19. This 10 to the power of 19, 10 to the power of minus 19 get cancelled. 3.2 divided by 1.6, 1.6 2s are, therefore N is equal to 2. So here 2 electrons are missed, so that the charge has become 3.2 into 10 to the power of minus 19 coulomb. This is positive charge. Next problem. Now let us discuss problem number 3. What is the force between two small charged spheres having charges of 2 into 10 to the power of minus 7 coulomb and 3 into 10 to the power of minus 7 coulomb placed 30 centimeter apart in A, air, and B, in a medium of dielectric constant 4.5. Let us consider two charges. This is Q1 and this is Q2. So we know Q1 is equal to 2 into 10 to the power of minus 7. Here it is given. This is Q2. So this is the Q2. The distance between them, D, is equal to 30 centimeter. D is equal to 30 centimeter. As this charge is in SI system, that is coulomb, this distance must also be in SI system. So to convert the centimeter into meter, that is SI system, instead of C we have to take 10 to the power of minus 2. This is equal to 30 into 10 to the power of minus 2 meter. In place of C, I have to multiply 10 to the power of minus 2. So now according to Coulomb's inverse square law, this charge repels this one in this direction with force F. This charge also repels this one in this direction with the same force, but opposite in directions. Magnitude of these two forces, or force between these two charges, is given by F is equal to 1 over 4 pi epsilon naught Q1 Q2 by D square. We know the value of this 1 over 4 pi epsilon naught, that is 9 into 10 to the power of 9. So Q1 value is this much, let us substitute, and Q2 3 into 10 to the power of minus 7 divided by the distance square, that is 30 into 10 to the power of minus 2 whole square. So now look here, 10 to the power of minus 7, it is minus 14. Minus 14 plus 9, it is minus 5. And now 2 3s are 6 into 9. 9 into 6 into 10 to the power of minus 5. 30 square is 900. 10 to the power of minus 2 whole square. 2 2s are 4. So now this 0 0, 10 to the power of plus 2 minus 4, it is 10 to the power of minus 2. Therefore F is equal to 9 into 6 into 10 to the power of minus 5, 9 into 10 to the power of minus 2. 9 get cancelled and remaining thing is 6. 10 to the power of minus 5 minus 2, it comes minus 3. So F is equal to 6 into 10 to the power of minus 3 Newton. Newton is the unit of force. So this is the force between these two charges when they are in air. Now let us discuss the force between the same two charges when they are placed in a medium like this. Look here, let it be medium. Of course its dielectric constant is 4.5. For force between such two charges in medium, the formula is like this: 1 over 4 pi epsilon naught into epsilon r. This epsilon r has to be multiplied Q1 Q2 by D square. Take this one this side like this. Look here, this is 1 over epsilon r. 1 over 4 pi epsilon naught Q1 Q2 by D square. This much. We have already calculated here 6 into 10 to the power of minus 3. Therefore this Fm is equal to 1 by epsilon r into the value of this one is 6 into 10 to the power of minus 3. And epsilon r is 4.5. Therefore Fm is equal to 6 into 10 to the power of minus 3 divided by 4.5. Calculate the value of this one by using calculator. We get Fm is equal to 1.333. What is the unit of force? It is Newton in SI system. Therefore Fm is equal to 1.333 newtons. This we have to, this unit we have to mention. If you don't mention this unit, you will lose 1 mark, even though this answer is correct. So now look at these two forces. This is the force when these two charges are in air medium. So this is the force when these two charges are in medium. Look here, when dielectric medium is placed or when these two charges are in dielectric medium, compare the force. This is 6, this is 1.33. It means it is decreased, the force is decreased inside the dielectric medium. So this is about problem number 3. Next problem. Now let us solve problem number 4. The electrostatic force on a metal sphere of charge 0.4 microcoulomb due to another identical metal sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. Find the distance between the two spheres and also the force between the same two spheres when they are brought into contact and then replaced in their initial positions. Given here two charges are there, let one be q1 which is equal to 0.4 microcoulomb, it is positive, and q2 minus 0.8 microcoulomb. So here the force between these two charges is 0.2 newtons. As these two are opposite charges, this force is attractive. The distance between them has to be found. A r is equal to what? Next, look here, after contact we have to find the force. So now let us understand the problem. Here there are two spheres, identical metal spheres. It is charged and the charge on this one is 0.4 microcoulomb positive. Let it be represented by 4 positive signs. And here this is minus 0.8 microcoulomb. This negative charge is represented by negative sign, 8 negative signs. So now when these two spheres are brought into contact, look here, these 4 positive charges neutralized by these 4 negative charges. Therefore, out of 8 negative charges, 4 are remained. As these two metal spheres are in contact and they are identical, these 4 charges are distributed equally, and 2 charges here and 2 charges here. So now they are brought to their initial positions like this. So on this one 0.2 microcoulomb and this one also 0.2 microcoulomb, both of them are negative. As they are negative, this repels this charge in this direction, and this sphere due to charge repels this sphere in this direction. So this force has to be calculated. This is F2, actually this is F2. So now let us discuss one by one. First let us calculate the distance between them so that the force is 0.2. According to Coulomb's inverse square law, F is equal to 1 over 4 pi epsilon naught q1 q2 by r square. F is there, F1 it is 0.2, and 1 over 4 pi epsilon naught is 9 into 10 to the power of 9. Q1 this much, Q2 this much, and divided by the distance square r square. So cross multiply this one, we get r square is equal to 9 into 10 to the power of 9, this much divided by 0.2. This 0.2 is cross multiplied here because we have to calculate the value of r. So now this 10 to the power of minus 6 it is minus 12. Minus 12 plus 9 it is minus 3. So 0.4 into 0.8, 0.332, and therefore r square is equal to 9 into 3.2 into 10 to the power of minus 3 divided by 0.2. So when this is calculated by using calculator, we get r square is equal to 14.4 into 10 to the power of minus 3. Transpose this square this side, it becomes square root, and here under square root 14.4 into 10 to the power of minus 3 is there. So this is the important step. We don't have to bring this 14.4 out of this square root, because this 10 to the power of minus 3, it is very difficult to bring this out of the square root. Therefore this minus 3 has to be made even number. By shifting this point right side, this becomes minus 4. So now it is 144 into 10 to the power of minus 4. Now it can be easily brought out of this square root. Look here, the square root of 144 is 12. The square root of 10 to the power of minus 4 is minus 2, 10 to the power of minus 2. The unit of distance is meter. So 12 centimeter. This is the distance between these two charges. So that the force is 0.2 Newton. Now the second point. What is the force after contact? Now look here. After contact, the total charge is 0.4 minus 0.8 microcoulomb. Total charge is equal to minus 0.4. When this is divided by 2, we will get minus 0.2 into 10 to the power of minus 6. Q1 is equal to Q2 is equal to so much. This is after contact. And F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square. Here F has to be calculated. This is F2. And here F is equal to 1 over 4 pi epsilon naught is 9 into 10 to the power of 9. Q1 minus 0.2 microcoulomb. Q2 is also minus 0.2 microcoulomb. And the distance we have already calculated. That is 12 into 10 to the power of minus 2. That square. So here minus into minus, it becomes plus. 10 to the power of minus 6, minus 6, minus 12 plus 9 is minus 3. And 9 into 0.2 into 0.2 we have to calculate. So F2 is equal to 0.36 into 10 to the power of minus 3 divided by square root of this 12 is 144. 10 to the power of minus 2 square is 10 to the power of minus 4. So now by calculating this one, we get F2 is equal to 0.025 Newton. This is the force between two charges after connecting them and replace them into their initial positions. So this is problem number 4. Now let us discuss problem number 5. Two identical metallic spheres having unequal opposite charges are placed at a distance 0.9 meter apart in air. After bringing them in contact with each other, they are again placed at the same distance apart. Now the force of repulsion between them is 0.025 Newton. Calculate the final charge on each of them. Now let us take the given distance before and after. Look here, this is the distance. It is represented by R. It can also be represented by D is equal to 0.9 meter. And next the force after contact. Look here, force is given 0.025 Newton. And charge after contact. Let the total charge be Q. So this charge is divided into two parts on each spheres. As they are identical, equal charge is divided, that is Q by 2. Charge on each sphere is equal to Q by 2. Now let us understand the problem. Look here, this is the sphere and this is another sphere. These two are identical. Let us suppose there is some negative charge on this one. Let it be minus 8. As in the problem it is told unequal opposite. If it is negative, it has to be positive. And let it be 12 plus 12. It is represented by positive signs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here 8 are there. The distance between them is 0.9 meter. Now they are brought in contact like this. So when they are in contact, these negative charges get neutralized with these positive charges. Suppose this is minus 8. 8 of positive charges and 8 negative charges get neutralized. remaining 12 minus 8, it is 4. Let this is the charge Q. This charge, the total charge on these two spheres is Q. As these two spheres are metallic and identical means same radius, this charge Q is equally distributed on the surface of these two spheres. So Q by 2 on this one, Q by 2 on this one, like this. Look here, 4 by 2 is 2, 2, like this. So let this total charge be Q and charge on each sphere be Q by 2. Now they are brought to the same place like this. Now what is the force between these two things? That is 0.025 Newton. And now we have to calculate total charge and charge on each sphere. Okay, according to Coulomb's inverse square law, F is equal to 1 over 4 pi epsilon naught Q1 Q2 by d square. Here Q1 is Q by 2, Q2 is also Q by 2. So therefore, look here, instead of Q1, Q by 2, Q by 2. Q square divided by 2 2s are 4. So look here, therefore, now substitute for F 0.025 Newtons. Here it is given. And we know 1 over 4 pi epsilon naught is 9 into 10 to the power of 9. And d square, distance, is given 0.9 square. Okay, now Q square divided by 4. So here this Q square by 4 can be written here 4 into 0.9 square. So therefore 0.2, look here this thing, 0.025, shift this point 1, 2, 3 right side. So we have to raise minus 3 like this. This is equal to this one 9 into 10 to the power of 9. Q square divided by 4 into this 0.9 can be shift this point this side, 9 into 10 to the power of minus 1 square. So here 25 into 10 to the power of minus 3, 9 into 10 to the power of 9, Q square divided by 4 into this square, that is 9 square, into 10 to the power of minus 1 square is 10 to the power of minus 2. Of course 9 square is 81, but as in the numerator 9 is there, don't multiply because it is easy to cancel the square and 9. So this 9 and square get cancelled. Now this comes 10 to the power of 9, and here it is 9 4s are 36. And of course 10 to the power of minus 2 is there. This is taken to the numerator. It has become plus. And now 10 to the power of 9 plus 10 to the power of 2. 9 plus 2, it is 11. Now let us cross multiply this 36 here and 10 to the power of 11 here. We get, look here, 36 has come here, 10 to the power of 11 here, and Q square. We need Q. So now look here, Q square is equal to 36, 25, 10 to the power of 11. If we take it to the numerator, it becomes minus. Minus 11 minus 3, it is minus 14. Of course, don't multiply this 36 into 25 because if this square is transposed, it becomes square root. Of course, square root of 36 is 6. Square root of 25 is 5. It can be easily taken out of the square root. Now, Q is equal to square root of 36 into 25 into 10 to the power of minus 14. So, Q is equal to 6 6 is 36 and into 5 5 is 25 into 10 to the power of minus 7. 6 5 is 30. So, this is the total charge on two identical spheres. Now, new charge on each sphere, it is Q by 2. So, that is equal to 30 into 10 to the power of minus 7 divided by 2. So, 30 by 2, it is 15. So, 15 into 10 to the power of minus 7. So, this is the value. This is the charge on each sphere. And here we have to mention the unit, SI unit of charge, it is Coulomb. So q by 2 is equal to 15 into 10 to the power of minus 7. This is the problem number 5. Problem number 6. Calculate the distance between two protons such that the electrical means electrostatic repulsive force between them is equal to the weight of either proton. Given charge on each proton is equal to 1.6 into 10 to the power of minus 19 coulomb. Mass of proton is equal to 1.673 into 10 to the power of minus 27 kg. Acceleration due to gravity g is equal to 10 meter per second square. Here it is actually 9.8, but it is given 10 to make calculations easy or simple. Now let us understand the problem. There are two charges. These two charges are protons. Here it is given. And of course, the distance between them has to be calculated. Look here, calculate the distance between two protons. That is d is equal to what? Next, charge on this one is equal to charge on this one. Therefore, q1 is equal to q2, which is equal to qp. Charge on the proton, it is given 1.6 into 10 to the power of minus 19 coulomb. So this is the charge on electron. Of course, charge on proton is equal to charge on electron, but on proton it is positive, on electron it is negative. Magnitude is same. So now mass of proton is given. This is equal to 1.673 into 10 to the power of minus 27 kg. And now according to this problem, electrical repulsive force between them means two protons is equal to weight of either proton. Either means any one of the proton. So force between charges is equal to weight of a proton. This electrostatic force is represented by F and weight is given by mg. So this force is given by Coulomb's inverse square law, 1 over 4 pi epsilon naught q1 q2 by d square, which is equal to mg, and take it as it is. And here as we need d square, and you cross multiply this one here and mg here like this, and as q1 is equal to q2, let them be q and q. So q and q square. Therefore 1 over 4 pi epsilon naught q square by mg is equal to d square. We know 1 over 4 pi epsilon is 9 into 10 to the power of 9, and q value is given. So that is 1.6 into 10 to the power of minus 19 square divided by mg. Mass is given, so it is so much, into g it is 10. This is equal to d square, this one. And here 1.6 into 10 to the power of minus 19 square is there. Therefore 1.6 square is 2.56, 10 to the power of minus 19. Minus 19 into 2 it is 38, and divided by 1.63 into 10 to the power of minus 27 into 10 to the power of 1 it is. Now look here, minus 38 minus 27, it becomes minus 11. 10 to the power of plus 9 plus 1, it becomes plus 8. Therefore here it is 9 into 10 to the power of 8, because 10 to the power of 1 is there. 2.56 into 10 to the power of minus 38 minus 27, 11. So 1.673. We need d square. By using calculator, you can calculate the value of this much. Multiply 9 into 2.56, divide it by 1.673. We get d square is equal to 13.77 into 10 to the power of minus 3. Transpose this square this side, we get square root of 13.77 into 10 to the power of minus 3. Here some attention is required. We should not take this immediately out of the square root. Let us observe this power minus 3 is there. It is not simple to take it out of this square root. It becomes simple if it is made even. Here it is odd number has to be made even, that is minus 2 or minus 4. So by shifting this point this side, left side, this becomes 10 to the power of minus 2. It is like this. And now you take this 1.377 out of the square root. That becomes 1.17 into square root of 10 to the power of minus 2. That is 2 by 2 is minus 1. So now as this is minus 1, shift this point left side. You get this much. So the distance between two protons is equal to 0.117 meter. This is the SI unit of distance. So this is the answer. Problem number 7. Determine the magnitude and direction of electric field which would balance the weight of a proton placed in the electric field. Given mass of the proton is equal to 1.67 into 10 to the power of minus 27 kg. Charge on the proton is equal to 1.6 into 10 to the power of minus 19 coulomb. Now this electric field has to be calculated. Mass of the proton is so much and the charge on the proton is 1.6 into 10 to the power of minus 19 coulomb. Now let us understand the problem. Here there is an electric field. Let us assume this is the positive plate, positively charged plate. It produces field like this. The direction of the field is upward. When a proton is placed in this field, it experiences force. The force experienced by the positive charge is in the direction of the field. The field is upward, therefore the force is upward. This is F. This is electrostatic force. As proton has mass, it has weight, that is gravitational force, it is downward. It is given by mg. As these two forces are equal and opposite, it is balanced. It means it neither moves upward nor downward. Therefore F is equal to mg. That is electrostatic force is equal to weight of the proton. Electrostatic force is given by the electric field at this point into charge at this point, that is EQ, and W we know mg. Here we need to calculate E, cross multiply this Q. So substitute for M, G and Q. So M 1.67 into 10 to the power of minus 27. Of course G we know 9.8. Charge on the proton is 1.6 into 10 to the power of minus 19. This can be calculated by using simple calculator, and we get this much, 10.23 into 10 to the power of minus 8. This 10 to the power of minus 27 minus 19, it gives minus 8. The SI unit of electric field is Newton per coulomb. It is very important to mention the unit. Otherwise, in the exam, you will lose 1 mark. Problem number 8. Find the strength of the electrostatic field whose force on an electron is equal to the weight of the electron. Given mass of the electron is equal to 9.1 into 10 to the power of minus 31 kg. Charge on electron is equal to 1.6 into 10 to the power of minus 19 coulomb. This problem is same as the problem number 7. So here given E is equal to what? M is equal to so much, Q is equal to so much. Here the force, electrostatic force, is balanced by the weight of the electron. So from the problem, EQ, this is electrostatic force, is equal to weight mg. We need E, cross multiply and substitute for M and G and Q. We will get like this, 9.8 divided by 1.6 into 10 to the power of minus 19. Now E is equal to 55.74 into 10 to the power of minus 12. It comes. The unit is Newton per coulomb. So this is the problem. A free pith-ball. Pith-ball means a very lightweight ball. A free pith-ball A of 8 gram carries a positive charge of plus 5 into 10 to the power of minus 8 coulomb. What must be the nature and magnitude of charge that should be given to a second pith ball B fixed 5 centimeter below the former ball, so that the upper ball is stationary? Given G is equal to 10 meter per second square. Here given mass is equal to 8 gram. This should be in kg. This 8 gram is equal to 8 into 10 to the power of minus 3 kg. Gram can be converted into kg by multiplying it with 10 to the power of minus 3. And the charge on pith ball is given, look here, this one, 5 into 10 to the power of minus 8 coulomb. Q2 is equal to what? D is equal to 5 centimeter. Here also it is in centimeter. It has to be converted into meter. By writing 10 to the power of minus 2 instead of C, we will get meter. That is 5 into 10 to the power of minus 2 meter, like this. And G is given 10 meter per second square. Now let us understand the problem. So look here, there are two pith balls. One Q1 above this Q2. The distance between them is D, that is 5 centimeter. And now this Q1 has some mass, therefore it has weight. Gravitational force is given by mg. As Q1 and Q2 are of same type of charges, this Q2 repels Q1 in this direction, upward direction, and it is given by F, electrostatic force. This electrostatic force balances the mass, that is weight of this Q1. Therefore, it is neither moving up nor moving down. It means balancing. So, this F is equal to mg. The magnitude of the electrostatic force is equal to magnitude of the gravitational force. So, we know as there are two charges and distance is there, the force, electrostatic force, is given by 1 over 4 pi epsilon naught Q1 Q2 by d square. This is equal to mg. Here we need to calculate Q2, this one Q2. We know 1 over 4 pi epsilon naught is 9 into 10 to the power of 9. Q1 is given 5 into 10 to the power of minus 8. Q2, it has to be calculated, and d square, distance, is given 5 into 10 to the power of minus 2 whole square. This is equal to m, mass, 8 into 10 to the power of minus 3. Here mass is given 8 into 10 to the power of minus 3 into G is given 10. So now this 9 5s are 45, and 10 to the power of 9 plus 9 is there, minus 8 is there. Therefore, it is 10 to the power of 1. So 45 into 10 to the power of 1 into Q2, this Q2. So 5 square 25, 10 to the power of minus 2 square minus 4. So this is equal to 8 into 10 to the power of minus 2, because minus 3, here plus 1 is there. Minus 3 plus 1 is minus 2. So now this Q2 is required, therefore cross multiply 25 here and this 45 here. So this is equal to 8, 25 is it is 200, 10 to the power of minus 2 minus 4, it is minus 6. 45 into 10 to the power of 1. So this is equal to, calculate it using calculator, 4.47 into 10 to the power of minus 7. Look here, minus 6. If this plus 1 comes to this numerator, it becomes minus. Minus 6 minus 1 is minus 7. So this must be the charge on this one, and it should be positive, because in order to repel this positive charge, it has to be positive. So its unit is coulomb. So this is problem number 9.